Project code ITPW01. Project title Adaptive Damped Circular Current Limit Control for PV Grid Tied System. Actually, in PV grid type of system, they mainly used to PV is connected with the grid. In between, the thumb rule is we connected the PV means connected the boost converter is necessary, and to connect the grid means we have to convert DC to AC operation. That is inverter operation is also there. But here they mentioned the double stage PV grid tied three phase system means the double stage they mentioned like boost converter with the inverter. They consider this as a two stage, and in a PV system conventionally P&O algorithm MPPT technique is used. In this proposed concept, instead of MPPT, incremental conductance system is used because for the dynamic response, dynamic changes in input solar irradiation to PV, the incremental conductance is good for tracking. It will correct the fault tracking. In existing concept, I already said that the P&O algorithm is used. P&O algorithm compare the duty cycle with the next depends upon the changing the power. At the point the maximum power reached, the duty cycle for the maximum power fixed, and the duty cycle is fed into PWM, and the pulse is given to the boost converter. This is a conventional model. The main drawback of the P&O method is mainly the fault tracking. Actually, in case the solar irradiation changes, throughout the day solar radiation is dynamically changes. Like in morning, it will change. Like that means afternoon high peak will be reached again, low will be reached. So the dynamic response, the sudden dynamic response, the P&O algorithm have the false tracking. False tracking means in case we put the P&O algorithm for the boost converter for the dynamic changes means that time the 0.43 we consider as a duty cycle, but we in case we use the incremental conductance means the accurate result like in that particular point 0.53 for P&O means in incremental conductance the accurate 0. In case 4 0.4 like that the accurate result will be coming from the incremental conductance algorithm. In a proposed converter, the double stage, the input panel is connected with the boost converter, and the boost converter is coupled with the voltage source inverter, and the three-phase output is fed into the grid. And then for nonlinear load, in case in grid the nonlinear load is connected means for the good response, the proposed controller like adaptive damped circular current limit control is used to give the pulses to voltage source inverter as closed loop. And in a boost converter, incremental conductance algorithm is used. The proposed advantages first is tracking ability. Tracking ability is good when compared to P&O algorithm. And the computation burden also very low. The black diagram solar PV is connected with the boost converter and coupled to voltage source inverter and connected to load or grid. And boost converter already said that the incremental conductance, the proposed incremental conductance is used, and the voltage source inverter take the feedback from the load or grid, and proposed adaptive control technique is implemented to give the pulse to voltage source inverter. Mainly this proposed concept is used to grid connected application Second, we are used the solar panels for renewable energy application. Third, power compensation technique, because we use the voltage source inverter. In case the grid have this concept is used for STATCOM or DVR or UPQC. Some power compensation fact devices. This proposed converter is also used. This this proposed concept is implemented in a simulation using the MATLAB 2015 version, and in hardware prototype microprocessor lab is used to build the program and give to the PIC microcontroller. The PIC microcontroller produces pulses, which is given to our proposed converter. These are all the hardware requirements, minimum requirements. Mainly the MOSFET is used for both converter and voltage source inverter, and the transformer. Transformer give the A transformer is used to excite the PIC microcontroller. PIC microcontroller have 5 volt. In between regulator and diode bridge rectifier is used. And the solar PV 12 volt 10 watts panel is used, and other passive and active devices are used in our proposed converter. Thank you.